so you asked for video notes on orbitals, so here they are. Starting off, this is just some definition stuff. We were talking about that our energy level is our atom is the office building, the energy level is the floor, the sublevel is the room, and we're going to further break down the sublevel into orbitals, so you could consider orbitals like the cubicle of the whole electron cloud kind of thing. And it works out really well because each orbital can hold 2 electrons, and each cubicle typically holds 2 people. You kind of have the dividing like this and like this, and there's an opening here, and someone has a desk, and here's a desk, and a little person sits there, and a little person sits there. So you can kind of consider an orbital to be like a cubicle because each orbital can hold 2 electrons, each cubicle can hold 2 people. And this is just the definition of what an orbital is, and I want to make sure that you understand that an orbital is not an orbit. Bohr is what an orbit is what Bohr had kind of suggested as to what the electrons were doing, and that they're, here's your nucleus, and the electrons travel around the nucleus in these circles, of increasing energy. And while he was pretty spot on about the energy level thing, he was not right on with the whole electrons being stuck in an orbit. And so when Heisenberg came along and, figured out this whole orbital thing, I don't know if he just decided, hey, let's stick 2 extra letters onto the end of this thing to indicate that it's no longer just a circular path, and it's now this random 3D region around the nucleus. But that's the word that they came up with. So, whoops, sorry, went too far. This is just a review. This first little thing here is just a review from class on Friday, showing how many electrons are capable of fitting into each sublevel. Remember, you can find this information by counting the squares that's in that particular block on the periodic table. Well, since each orbital can hold 2 electrons, you can take all of these numbers and divide them by 2 to figure out how many orbitals are contained in each sublevel. And you notice here's a nice little pattern of odds. So when that mythical G sublevel decides to grace us with its presence, it'll have 9 orbitals and the possibility of holding 18 electrons. Now, granted, G's don't exist yet because we don't need them. So these are just some shapes that I want you to know. The sole S orbital is the shape of a sphere. That's how you can remember it. It's S, and it's a sphere. And there's only one of them. And this right here is a 3-dimensional axis. Usually you would have it as, here's what it is in geometry. You have the y-axis here, and you have the x-axis here. Well, if you wanted to represent 3-dimensional space, then you would have this line kind of coming out like this out of the page, and this one would go back into the page, and that would be your Z orbital. And I know these 2 letters are kind of reversed, but it's all right. Basically, all of these are right angles. So we have a right angle there. Here is a right angle to there, and there's a right angle to that one, right angle there, and then of course we have right angles. And so it's just a bunch of right angles. And so in 3-dimensional space, a sphere, it doesn't matter how you turn it, it's always the same. So that's why we only have 1 S orbital. P orbitals, we have 3, and they're all dumbbell shapes, and this is what they look like when they're all put together, and this is what they look like in their individual orientations. This little subscript right here tells you that this is the dumbbell shape that's in the x-axis, this one's in the y-axis, and this one's in the z-axis. After this sublevel with the D and F sublevels, you don't have to know the shapes, but just remember that S is spherical, P is dumbbell, and there's 3 of them. And then for the next couple slides, I'm just showing them just for artistic reasons, and but all you have to know is that D has 5. You do not need to know the shapes, nor do you need to know this little subscript annotation right here telling you which dimension the 5D orbitals are in. I always kind of remember these as they look like clover leaves, but then you've got this guy that looks kind of like a pacifier. And then you have the F orbitals, which are really crazy looking. Again, seriously, do not try to figure this out because, that's just ugly. The orbital is just a mathematical probability calculation, and so that's why it's got these, very algebraic looking terms right here. So, to sum it up, if you are in energy level 1, That corresponds to row 1 on the periodic table. And there's only one sublevel in energy level 1, and that's an S. And I'm just going to kind of get this up here, and then I'll talk a little bit. Energy level 2 corresponds to row 2. There are 2 sublevels, and it's S and P. Moving on, 3 and 4, they pretty much make sense in that, all the numbers match up. And it continues on, but at energy level 5, 6, and 7, you get some interesting situations going on here. Yes, energy level 5 corresponds to row 5, and there should be 5 sublevels, except that one doesn't exist yet. S, P, D, and F, 5S, 5P, 5D, and 5F, they all exist. But 5G doesn't exist yet. It might if we ever get like an 8th row on the periodic table. Energy level 6 corresponds pretty much to row number 6. There should be 6 sublevels, but again, we only currently have S, P, and D. There is no 6F. There is definitely no 6G, and I don't know what they're going to call whatever the 6th sublevel is. And then energy level 7 kind of goes back a little bit more. It corresponds to row 7. There should be eventually, maybe, possibly 7 sublevels. Currently, all we have, though, is 7S and 7P. And even 7P is, not filled up yet. 7D, 7F, 7G, and 7 whatever and whatever, they really, really don't exist yet and probably won't exist for a very long time. So this is the big table to really sum everything up and kind of find your patterns. Energy level 1, we already said it has one sublevel, and that sublevel is S. The number of orbitals that an S sublevel can have is only 1. Therefore, the total orbitals on this particular energy level is 1. And to find your total number of electrons, you take the total number of orbitals and multiply by 2. So you get a 2. Energy level 2, you can have an S and a P. The S's have 1 orbital, the P's have 3. Total orbitals is 4. Total electrons, 4 times 2, you can have 8. You'll start noticing a pattern going on over here on this side. Energy level 3 can have the sublevels S, P, and D. That S can have 1 orbital, P can have 3, D can have 5. Remember, these go up by odds. Add all this up, total number of orbitals for energy level 3 is 9. 9 times 2 gives us 18 possible electrons. These numbers should really start looking familiar to you now. And if you're quick at math patterns, these are probably starting to take shape. Energy level 4 is S, P, D, and F. For orbital numbers of S is 1, P is 3, D is 5, and F is 7. Add all those up and you get 16 total orbitals for energy level 4. 16 times 2 gives you 32 electrons. Pattern here is probably those numbers that your 8th grade science teacher told you to memorize, but then I showed you could just read them on the squares off the periodic table. Pattern here is that the total number of orbitals is always equal to the energy level squared. Energy level 1, 1 squared is 1. Energy level 2, 2 squared is 4. 3 squared is 9. 4 squared is 16. Pretty cool, huh? So total number of electrons is actually equal to 2n squared. Oh, I guess I should probably tell you that energy level is represented with an n. And the number of sublevels, number of those guys, of sublevels, is always equal to n. And so that's just kind of little ways that you can help remember these things. Remember, none of this is coincidence. All of this just, it's on purpose. These patterns are on purpose, so it makes it really nice and easy to remember. So that's all I got for you.